So today what we're going to do is we're going to talk about properties of isometries. And so basically today's going to be a fairly short lesson. All you're going to end up doing is we've got a few investigations we're going to talk about, and then you'll be let loose on your assignment. So let's go ahead and talk about this. And we briefly talked about this yesterday, so this should be a little bit of review. It says transform the polygon at right using the rule. xy to x plus 2, y minus 3. Describe the type and direction of the transformation and write it as a vector. So what we're looking at mainly is we're looking at this right here. And that says x plus 2, y minus 3. So what that means with each of these points here, I'm going to move the x positive 2, and I'm going to move the y negative 3. So from this point, move the x 2, positive 2, where am I going?
Up 2.
X
Over 2.
over 2, and then where do I go?
Down 3.
Down 3. So here's my new point
For just that
for
one.
this one right here. Now what I need to do is the same thing for this point. So I've got to move it x plus 2. So where am I going to go?
Over 2, down
Over
3.
2, and then down 3. So here's my new green point.
Is it going to be the same for each one?
Yep.
Over
So over here, I'm going to go over 2, and then down 3. And then last but not least, over here, I'm going to go over 2, and then down 3. So those are your new points, and then all you have to do is connect the dots. Okay, and so all I'm going to do here is I'm just going to go ahead and connect the dots. So here I'm looking at one right here. Here I'm looking at another one right here. Here I'm looking at, let's try that one again. Come on, there we go. And then here I'm looking at, oh, that one didn't work, but that's okay. You can get the figure, you can get the idea. There we go.
Are they all parallel to each other?
So then now, this is a translation because all I have done is I've shifted it down. I've shifted it to the right 2 and down 3. And so what they want you to do is they want you to go ahead and write that as a translation vector. So how we write a vector is we use brackets that look like this. That's how we write a vector. The first term, can somebody guess what the first term will be? 2. Good. What's the second term going to be?
3.
Negative 3. There you go. That's it. Okay? That's what the translation vector is. 2, negative 3. All it is whatever you moved your x and then whatever you moved your y. So you think you can handle that? That's the first part of your homework. Okay, fairly straightforward. Okay, the next part, let's go ahead and look at page 377, please. Page 377. What I'm going to go ahead and do, notice it says on graph paper, create and label 4 sets of coordinate axes. Okay, so I'm going to go ahead and pass around some graph paper, and I need you to go ahead and complete that, and then we will talk about the coordinate transformations conjecture. That. So let's go ahead and look at that. So if I just change the x to negative x, where does it move it?
To another quadrant.
I know, to what quadrant?
The one next to it.
It moves it across what? What axis?
The y-axis.
The y-axis. So this is a reflection across the y-axis. Okay, so if you just change the x's, it's actually a reflection across the opposite axis. So if you change the y's, what do you expect that's going to be?
Across the x-axis.
Across the x-axis, right. It's going to be across the opposite axis. What happens if it's both?
It's a reflection. Well,
This one is what you said, it's a
translation.
rotation about the origin because
Oh.
you're actually going to rotate it around. It could probably be, if you wanted to, it could be 2 reflections, okay? But a rotation about the origin, and then the last one, if you switch the x and y, that's just a reflection across the line y equals x. So I'll let you get those down, then we'll talk about our next investigation. Okay, so let's go ahead and look at our next investigation. So on page 377, the bottom of the page, you're going to notice it says finding a minimal path. And so it says in chapter 1, you used a protractor to find the path of the ball. In this investigation, you'll discover some of the properties of reflections that have many applications in science and engineering. They may even help your pool game. So if you remember back to what we learned about in chapter 1, we learned that the incoming angle the ball came in at equals what?
The outgoing.
The outgoing angle. So we found out that those equal the same. And so what our task today is going to be to find the minimal path that you can achieve, okay, in order to get this cue ball in the case in like a hole or something like that. And so the minimal path conjecture, I'm just going to go ahead and give this to you because it is actually a long conjecture. It says if points A and B are on one side of line L. So if points A and B are on one side of line L, then the minimal path from point A to point B is found by,
I'm gonna,
here we go,
Dang it.
reflecting point B across line L, drawing segment AB prime, then drawing segments AC and CB, where point C is the point of intersection of segment AB prime and line L. So I'll let you get that down and then we'll talk about that. So on page 378, what I want you to do is look at the top of the page, and on your patty paper, I want you to go ahead and complete step 1 in the top left. So you need to draw a line in, and then you need to draw 2 points, A and B. So draw a line in, and then draw 2 points, A and B. Page 378, the top left of the page, step 1. What?
look, I'm already done.
Yeah, I am.
Draw a line.
Okay, so go ahead, draw a line as it is in step 1. Draw 2 points, A and B. Okay?
Like this?
Points A and B are not on the line, right?
Oh. Look at my guy's face. It looks like a face.
So then now what we're going to do is we're going to find the minimal path from A to B. We're going to find that shortest distance. So step 1 from the conjecture, it says reflect point B across line L. So with your patty paper, take your patty paper, fold on that reflection line, okay, and then trace new point B. So we're going to call that B prime.
Wait, where do we fold?
Okay?
Like this?
So fold on the reflection line. Fold on the reflection line. Fold your patty paper in half.
On the line.
Okay? You see where your reflection line is.
Didn't know
Fold it
it was
on
a
and then draw the new B. So that is called B prime.
Mine's like almost at the edge of the paper.
Well, it's still a good thing it's still on the
Like
paper.
this?
So B prime. Yes, that'll work. Okay, so that is, we've reflected point B across line L. Now I need you to draw segment AB prime. So I need you to connect that point you just found, B prime, with point A. Okay, so connect that point you just found with point A and draw a line.
So they're going to cross?
Yeah, it'll cross the line. If you want to, you can follow along because this is still in step 5. So we just did that. Now we're going to draw segments AC and CB. Now what I want you to do, you're probably wondering where is C? You just drew line AB in, right?
Where
AB
the
prime.
intersect is C.
Okay, where AB and that line intersect, okay, that is point C. So we're going to call that point C.
On line N?
And that's on the line that you reflected. So where the X is, that's point C. Now what you're going to do is draw in AC and CB. You're going to draw in AC and CB. And that is the shortest distance from A to B when using that line.
This angle?
Yep. So that would be like if you were going to shoot pool or something like that. That's going to be your shortest distance.
Oh, like bring my conjecture
of
this.
It's point AB, you're on the line.
And we'll have like a
line.
table.
You will have.
Okay, so that is the shortest distance.
That was confusing.
All right, so now what we're going to go ahead and do is we're going to go ahead and look at your assignment. So your assignment is found on pages 380 through 381, numbers 1 through 11. Okay, now let's go ahead and look at this. 1 through 5, all you need to do is do the changes that it's told. We talked about those earlier. Okay.
Will you go through one of them?
Number 6, it says, look at the rules in exercise 1 through 5 that produce reflections. What do those rules have in common? Okay, how about the ones that produce translations? So basically, this is what you need to do. Compare all of your reflections, compare all your translations, tell me what you notice about the two. I need you to do 7 and 8. Basically tell me what is different, what did you do to the x, what did you do to the y to get the new figure. I need you to do number 9, it says what point on the W cushion can a player aim for so that the cue ball bounces and strikes the 8 ball. I'm actually gonna have you stop at number 9 and not go through number 11. Okay, so I'm gonna change that assignment so it's actually going to be 1 through 9, and that will be due tomorrow at the start of class.
Will you go through one of